So let us continue today's class. Last class we have discussed how to design a low pass Butterworth filter, and also we have spent time to discuss why we select a C and why we calculate R instead of doing a reverse. Many students they answered yesterday when this question was asked. And finally, select the value of R1 and RF depending on the desired passband gain. All of us know, as it is a non-inverting amplifier, gain is given by 1 plus RF by R1. Take a few seconds, just glance once. If it is there in your notebook, go through once. Then we'll consider one numerical example so that we can understand how to design a low pass Butterworth filter. Let us take a one numerical example. Design a low pass filter at cutoff frequency. All of you copy down. Design a low pass filter at a cutoff frequency of 1 kHz with a passband gain of, I repeat, design a low pass filter at a cutoff frequency of 1 kHz with a passband gain of 2. Write down the solution. FH is given as a 1 kHz, and instead of taking let R equal to, we have to take let C equal to 0.01 microfarad. Let C equal to 0.01 microfarad. Now calculate R. Try to give the answer, approximately how much it will come. Take a 1 minute. Try to write down the R equal to, just now you have glanced, R equal to the equation. Simply fill the value FH and C and find out the value of R and type your answer in the chat box. I'll be happy to see your name in the chat box. Equation is not big and no integration differentiation. Simply fill. Use a calculator. I don't know how many of you are having a calculator with you now. Very good, Pavan. Thank you very much. Even this same example is solved in the YouTube video. Even you could have noted that. I think Ulvesh has given, Pavan has given, Shreya Umrani. Thank you, Shreya. Most of the time you give the answer. Aditi, Vinay, Kirti, most of them, they are getting the same answer. 15.9 kilo ohms. And Pooja Kochibagi, or 2 times is there. Usha, Huldikashu, Umakant, Rakshita, Ashish, Pavan, Ganashri. All are getting 15.9 kilo ohm. And some people are writing 15.915 kilo ohm. That is correct. Sri Harsha, Harihara, thank you. And some people they rounding it and saying 16 kilo ohm. Very good. Most of you got the same answer. And let me show my answer also. I too got the same answer. 15.9. How to get a 15.9 kilo ohm resistors in our laboratory? If I am doing this particular experiment, you can take a potentiometer of 20K. Means pot or potentiometer. Adjust, rotate it to 15.9K you adjust. Then you can make use of it. Passband gain they are given 2. Let us take R1 equal to RF equal to same 10 kilo ohm and write down the circuit diagram. Have a habit of this. Whenever we say design, after calculating values, we need a circuit with those values. Then only I can say you have designed. So take a minute and try to write the circuit diagram of a low pass Butterworth filter and try to write down all the values. R, C value, And somewhere you can write down fh equal to 1 kilohertz and put a square bracket. Have a habit of writing neatly. You can see even my PPT also, as much as possible I'm trying to maintain very neat. So that's the habit, no? If you keep it, so definitely it will be helpful to you in the future. So now write down the circuit and write down the values. Hope most of you have completed. I'll give the another 10 seconds. Then we'll go to the next discussion. Remember, you have to write the circuit diagram with the component values, whatever you have calculated. Otherwise, you will not get a marks in the exam also. Remember, in the IA also. Now, frequency scaling means what? See, just now you have completed. Hope it is visible to you people. A design a low pass filter at a cutoff frequency 1 kHz. Just now you did it. Pass band you have taken it 2. Now, I want to make it a 1.6 kHz. What to do? Instead of following the same procedure once again, we can go for frequency scaling. Because all are same, only gain is changed. Not to go again for a design, simply go for a frequency scaling. What is that frequency scaling? Simply either change the R or C. Which one you have to change? Which is better to change, whether I have to change the C or whether I have to change the R to get a 1.6 kilohertz, whether I should give a priority to the change in R. Always, very good always. Rakshita, Shreya, Ashish Kulkarni, Anusha, Pooja, everybody is so active. I'm so happy today to see so many names on the chart. All are saying Aditi, Vinay, Preeti, Sita, Namita, Kirti, Siddhartha, Nayana, Sriranga, Pooja, Shivam, Tripathi. Very good. Everybody is saying R because yesterday I spent a lot of time to discuss R or C. Which one is better? So today everybody has told. This we expect as a teacher. No? Whatever I taught yesterday, if you tell today, I am so happy. Not only me, any teacher will become happy whenever you learn something. Now frequency scaling, a procedure used to convert an original cutoff frequency fH to a new cutoff frequency f-h is nothing but a frequency scaling. And it is accomplished. How we can do it, sir? Multiply R or C, but not both. This is very important. It's a one common mistake. Most of the students, they do it. Instead of doing only R changing, they will change both. Then frequency will become different. So how much I have to change, sir? R, for example, by the ratio of original cutoff frequency to the new cutoff frequency. We'll see a numerical example. You may not understand by reading a sentence. We'll see one numerical example. And variable capacitor is not commonly used. Just now this question I asked to you people. Should I go for R and C? Most of you told, no sir, you have to go for R only, not C. We don't have like a potentiometer variable capacitor. Therefore, better to use potentiometer. All of you have told this. Now, take a minute, copy down at least one line, meaning of frequency scaling. I read that. Procedure used to convert an original cutoff frequency fH to a new cutoff frequency f-h. Procedure used to convert an original cutoff frequency fH to a new cutoff frequency f-h is called frequency scaling. And you should multiply either R or C. You have to multiply either R or C by the ratio of original cutoff frequency to new cutoff frequency. Original cutoff frequency to new cutoff frequency. Hope most of you have copied, even I dictated, I give this time, same time. Let us go to the one numerical example so that all of you can understand meaning of frequency scaling with a numerical example. Using the frequency scaling technique, convert a 1 kilohertz cutoff frequency to a new cutoff frequency 1.6 kilohertz, a low pass filter what you had designed just now. This is a question. Use a frequency scaling technique to convert a 1 kilohertz cutoff frequency of a low pass filter to a cutoff frequency of 1.6 kilohertz. Note on the question, if somebody is good, he can do the problem, solve it and tell the value of R. Otherwise, steps I'll give you. Read it. Hope most of you have a calculator because you have told the answer. Let me wait for 1 minute, and if nobody gives, then I'll try to show the steps. We have given the steps in the previous slide. The ratio you have to take, that ratio should be multiplied to the resistor. Whatever the R value you get, that you have to type in the chat box. Very good, Rakshita, Namita. Namita given the R value, Rakshita has given the that ratio 0.625. Vinayak Damodar has given. Vinayak tried to have a habit of writing a kilo ohm or ohm. Thank you. Omkar has also written. Pooja Kalyan Mutt has written. So good to see. But please remember, write K or is it only ohm? 0.625 ohm, Shreya. It's not a 0.625 ohm. This 0.625 you have to multiply with the original R, Shreya. And one more guy has written Vishal. Vishal is correct. 0.625 has not mentioned the ohm. And Kirti, Manchunatha, Vinayak, Umakant, Abhinandan, Preeti, Rakshita, Pooja Kochabagi, Totashri, Amogh Kulkarni. Majority are getting the same answer. Do you know, if you have a students like this, definitely a teacher will be so happy always. And now let me show the answer what I got. Sri Harsha has given 0.625. Basava has given 9.9 kilo ohms. Ashish Kulkarni has given. Most of the names I am seeing now in the chat box. So happy to see all the names and call their names. In the class we used to call attendants, but now it is easy to remember the names. Shreya Umirani, very good. Siddhartha has typed 9.9. Let me show you the answer. C is same, 0.01 we have taken. The R is 1.2 pi. Simply you have to replace that C value and calculate. We got a 15.9. And whether you have to change R or C, we have discussed all this. R we have to change. And the answer is 0.625 is correct. And when you multiply this, you will get a 9.9494 kilo ohm. Those who have not got the answer, those who were having a difficulty to understand, now they can understand. And they can copy it on the original cutoff frequency divided by new cutoff frequency, which is 0.625. Therefore, this 0.625 I had to multiply with a 15.9 kilo ohm. I got 9.9. Again, you can take a 10 kilo ohm potentiometer, adjust to that 9.9 whatever is there. Again, now recalculate FH. In the exam, what you have to do, what you have done is correct or not to check it. Recalculate filling this value and find out FH and type your answer in the chat box. How much you should get out of frequency. Recalculate the frequency and type your answer in the chat box. All of you know the equation. Very good, Pawan. 1.6 kilohertz. Pawan, many students are typing. Gulvesh, Vinay, Naina, Ganashri, Sita, Totashri, and Rakshita. Kulkarni has typed 1.6. Manjunatha, Dodimani, Vishal, Umakant, Preeti, Usha, Akshay. At a time, many students will type answers, so difficult to read everybody's name. Divya, Ashish Kulkarni, Pooja Yam Patil. Many Poojas are there. And Parvati has typed 1.6. 1.596 Basava has got. Okay. 1.596. Okay, good. So it's 1.6. Most of them they are getting. That's the correct answer. And no doubt you should get 1.6 only. Because if you are taking 9.9 something like that in the resistor value, automatically that frequency also little deviate. If you take 9.9494 something, that completely it will come 5.999 something. So 1.599, automatically it's a 1.6 kilo ohm. Thank you. Let me go to the next. Hope most of you have done it, and let us go to the next. Summary, whatever you have discussed so far. A filter means what? Types of filters, most commonly used filters, frequency response of a filter, active filter, passive filters, first order Butterworth low pass filter, gain equation, how to design the filter, frequency scaling with numerical examples. These things we have discussed. Take a 40 seconds, just glance, go through your notebook. Have a habit of writing. Don't think nobody is going to see because it's an online class, nobody check my notes. Don't do that, because writing habit is very important. There is a saying, 10 times reading is equal to 1 time writing. That's the reason many times we ask you to write. When you may be remembering in your childhood, many teachers, parents used to ask you to write. Repeatedly you write. We used to write 10 times, 20 times. Reason is, when you write, you will remember for a longer time. Hope all of you have gone through whatever you have copied, all these things, so that you can go to the next. Let us go to the next. Now we have to go for a second order low pass Butterworth filter. Second order means what? Can you type in the chat box? Second order, first order, difference is what? In the second order, what changes we expect? Very good, Vinay, Vinayak and Preeti and Rajat, Ulvesh, having two capacitors. Tota Shri has typed, Aditi, so nice to see all names, Pavan, Shreya, Umarani, Muttu, Sunigar. So instead of one capacitor, we use two. When I say two capacitor, definitely two resistors will be there. Huh? Rakshita, Usha and Divya, Ashish, Siddharth. Two capacitors we use. That's all. Hope you people can understand. Instead of one RC, we are going to take two R and C. Srirang, Ritin, Amog, Parvati and many students. So this is a second order low pass Butterworth filter. So you can see here, I have one RC, another RC, and this R1 and RF I am taking as it is. Only changes is, instead of one RC combination, I am taking two RC combination. And some questions will come in your mind. Even sometimes, being a teacher, we also may not tell why it is like this only. And one more will come here. The gain should be 1.586. Why it should be? It's very easy to ask why. Remember, we have taken some heading. It is a low pass Butterworth filter. It is suggested by this particular person. That is the reason we have to follow whatever the design procedure is given by this particular person. That's called as it is a Butterworth filter. If I do something else, it will become a something other filter. Each filter design is different. We have discussed many types of filters are there. So if I design entirely different filter which is not at all there, then it is called as your filter. For example, Amog filter, Ritin filter, Sriranga filter. But its performance is good, we can give your name. If performance is not good, then nobody will use it. Let us go to the next. Just copy down a stop band response having a 40 dB per decade roll off. Gain is set by R1 and RF, and FH is given by equation 1 by 2 RC was there. Now square root of R2 R3 C2 C3. Just take a 1 minute and copy down. But this I have highlighted. It's not a 20 dB. It's a 40 dB. Many students in the exam, they forget to say 40 dB. They write 20 dB, but here they will write 2. So take a 1 minute, write down the circuit diagram in your notebook. Don't say I will take a snapshot, sir. I will take a Xerox, sir. Sir, it is already there in notebook. It is there in textbook, sir. Why should I write? Remember, writing habit is very, very important. That's the reason we people ask you to write. Parents and elders, they ask you to write because it becomes a habit. Otherwise, difficult to remember. If you write next time without seeing, it is very easy to write. If you see 10 times also, first time when you are writing, you'll face a problem. Something you'll miss. So have a habit of writing. And many students, they short this also. Sometimes they will ground here only. They make a lot of changes in this. Then that will never be called as a Butterworth filter. That will be called as that student name filter. That's all. Because this is given by a Butterworth, and we had to write the Butterworth filter only, not our own filter. So take another 30 seconds, write down the diagram, and already all of you have conducted the experiment in the lab. Some students might have completed, but copied. Even the PDF is available with all the students, and I hope most of you may be having a textbook also. Okay, hope most of you copied on properly. It is a 40 dB per decade. It is a stop band, it is a pass band, it is a gain, it is a frequency, and write down the ground properly. Have a habit of writing a ground properly. Otherwise, it is very difficult to understand ground and arrow mark. Both will be same in most of the. And polarity also, if you change, it is a dangerous. Polarity you should not change. Many students, they write plus and minus. क्या हुआ सर, जरा सा change हुआ है. That's why instead of giving a 1-0 marks, I have also given jara sa change, 0-1 I have given, that's all. So please remember, polarity you have to write down properly. Hope most of you have completed copying this, and let me go to the next. And for this, we don't have a derivation. Directly you have to remember the equation V0 by Vn equal to. No sir, I want to study derivation, sir. Whether you ask in the exam or not, whether it is there in the syllabus or not, I want to study. Very good. If such students are there, I am happy. Let them go to the appendix C of the book. A complete derivation is given. They can practice, they can go through. As of now, for the syllabus, if you remember gain equation, it's enough. Copy down this V0 by Vn equal to AF by square root of 1 plus F by FH raised to 4. AF is given by 1 plus RF by R1. It's a passband gain. F equal to frequency of input signal. So just copy down this. Already have copied these one or this, I think. You can copy down those. A derivation is there for a first order low pass filter, and first order high pass filter also you have a derivation. But second order, you are supposed to remember the V0 by Vn, and design will remain same. Procedure will remain same. Only FH equation is different for a second order low pass Butterworth filter, and remaining procedure is same, but one important point is here, which I will show you in the next slide. If you do not remember that, then everything will go wrong and all the marks you are going to lose. So this is one point which I am going to show you in the next slide. Let me wait for another 5 seconds. Yeah, filter design. Design steps are identical to the first order type. Choose a FH, R2 equal to R3 equal to R, C2, C3 equal to C, so that I will only talk about R and C. Then choose a value C is less than or equal to 1 microfarad. These steps are same. Calculate the value of R 1 by 2 pi FSC. The FH is a frequency you have chosen. Because R2 equal to R3 and C2 equal to C3, gain has to be equal to 1.586. This you have to remember for a second order low pass Butterworth filter. Choose the R1 value less than or equal to 100 kilo ohm. Once if you choose the R1, remaining you can calculate. And RF is 0.586 R1, because total I want 1 plus RF by R1 should become equal to 1.586. 1 plus is already there, therefore 0.586 R1 I need. And total gain is given by, just now I told, 1 plus RF by R1. So copy down this Steps are same. Choose FH. Then set R2, R3 equal to R, C2, C3 equal to 1, C. Choose a C equal to less than or 1 microfarad. Calculate R equal to 1 by 2 pi FHC. And because R2 and R2 equal to R3, C2 equal to C3, gain should be 1.586 for a Butterworth. Second order low pass filter. Choose R1 and RF equal to, choose such that total it should become gain 1 plus RF by R1 equal to 1.586. Sir, I want to know the whole derivation for a second order. Please go to the appendix C in the Gaikwad. All the information, complete derivation is given in that. Hope most of you are completed. Let me wait for another 5 to 6 seconds. Then we will go to the next slide. Yeah. Design a second order. All of you copy down. I'll dictate. Design a second order low pass filter at a high cutoff frequency of 1 kHz. At a high cutoff frequency of 1 kHz, and draw the frequency response of the network. Copy down this. You can take another 10 to 15 seconds. Those who are not copied, it's the same. Low pass filter only. High cutoff frequency is 1 kHz, but instead of first order we are talking about second order. So now do this. Let FH equal, now given FH equal to 1 kHz, let C2, C3 equal to 0.0047 microfarad, so that everybody in the exam also usually try to take a C is equal to either 0.01 or 0.0047, any one, so that answers will be unique for most of the students. I don't know whether let us take C2, C3 equal to 0.0047 microfarad. Take R1 equal to 27 kilo ohm, R2, R3 equal to R equal to, find out using 1 by 2 pi FC. Rakshita has typed some answer. 33.862. Yeah, Vinayak also, Damodar has typed. Very good, Vinayak. Vinay has typed 33.862 kilo ohm. Thank you to all the students, Pavan, Namita, Hiremat, I think Abhinandan Appannavar, Ganashri, all are getting same answer. Okay, Totashri, Sahana, Kirti, Pooja, Nayana, all are getting same answer. And let me show my answer also. Totashri has typed again. And Vishal, Mamdapur, 33.8. Okay, let me check. Yeah, I too got a same answer, 33.86 kilo ohm. So what you have to do, 33 kilo ohm you can use, and RF equal to, you find out and write down. RF you will get a 15.82. Copy down this and try to understand this. Substitute the value of F from 10 Hz to 100 kHz in this. FH is given to you, it's a 1 kHz. Find out the gain and gain response, you can plot it. This is a procedure. In the exam they may ask, they may not ask, but you should know what you have to do. Pooja Kalkani has typed the answer, 33.86 kilo ohm. Srirang, Omkar, Abhishek, Kiran CB, most of them they have typed the same answer. Thank you each one of you. So hope all of you understood how to do it, but this will take a time. I am not asking you people to do it now, but procedure you should know. In the question they ask you to draw now. So how to do it, sir? FH is given, F you vary from 10 Hz to 100 kHz, fill, calculate, then you can plot it. Whatever we have discussed so far, summary I am showing you. Just revise: a low pass filter, order of the filter, first order Butterworth filter, design of first order Butterworth filter we have discussed, examples we have discussed, frequency scaling we have discussed, frequency scaling with example we have discussed, design of second order Butterworth filter we have discussed, with example how to design also we have discussed. Just go through what all we have discussed so far. Take your notebook, glance once, because revision is very important. Usually forget within 2 to 3 days more, and somehow if you manage to remember for 2-3 days, it will remain for a longer time in your mind. So meaning of frequency scaling, how it can be done, just glance once or twice so that it will be easy for you. Let me wait for another few seconds, then we'll go to the next. Okay. Now, a last part is remaining in the filter. We have discussed first order and second order low pass filter. We have discussed first order high pass filter. High pass filter we have to discuss first order and second order. Now this high pass, band pass, Butterworth filters, I made one video and I have given a name filter 3. It is available in the YouTube. Those who are interested, they can go through. And this is a image what you get in the YouTube. Prerequisite already it's over in the class, and this is what we are going to discuss. A first order high pass filter, derivation of the gain, second order high pass filter. That's all. For your reference, if a time permits, I will show you a wide band filter, stop band filter, all pass filter. These are not in the syllabus. There is a reason the color is not dark. It's not completely black. Just for your reference, I may show if we have a time. High pass Butterworth filter. It is found simply by interchanging the RC. And above FL frequencies are pass band. And this is a way. This is a pass band. This side is a stop band. And because it is a first order, it is a 20 dB per decade. What you are going to get. So just read it once or twice. So before we go to the diagram, circuit diagram, how to get a high pass is simply interchange the RC position and you will get a FL, and circuit it almost looks same only. Instead of R and C, we are writing C and R. Copy down the circuit diagram and response so that we can derive the equation, gain equation. V naught equal to, can you type equation V naught equal to? Gain all of us know 1 plus Rf by R1. What is the V naught equation equal to? Last class we have already taken and all of you have typed the answer, and I want you people to do now also. Yeah, Preeti has typed, many has typed at a time. Vinayak, Anusha has typed 1 plus Rf by R1 into V. Some people they are typing V in, gain into V in they are typing, and some people they are typing 1, V1. Which is correct, you people should say. Let me, yeah, I think now again Akshaya is typing into V in, Sahana is typing into V1, and Sri Harsha is typing into V1, and Abhinandan is typing into V in, Kirti is typing into V in. Yesterday what you had done, it is the same combination. See, yesterday what you had taken, the circuit was same. Hope all of you can understand. This side I had a capacitor. This side I had a resistor. Only that is a difference. What equation you have taken? either gain into Vn you have taken or gain into V1. Let us consider this as a V1 for our reference. Whether you have to take V1, understand that. Yesterday what you have taken, how you have taken, similarly today I have to do. Whatever the input I am giving to this particular terminal, that will be amplified by how much? 1 plus RF by R1. जो भी आप इधर देते हैं वो एम्पलीफाई होता है कितना? 1 plus RF by R1. आप क्या दे रहे हैं इधर? Are you giving a Vin directly here? Check it. If this both two are not there, directly if you are connecting a Vin to here, then definitely gain into Vin is correct. Now, some components are there here. Because of that, voltage divide will be there. Therefore, part of Vin will be given as a input to the non-inverting terminal. This I explained yesterday also. Once again I am repeating. Hope you will understand. So now first I have to check what is the voltage at this point. Then gain into this point will become a output voltage for me. Listen carefully, be active, and now I am going to show you the same thing. So here I have written here V1, and V1 voltage is nothing but a voltage across the R, and all of you know gain is given by 1 plus RF by R1 into not directly Vin, voltage drop across the resistor. How to calculate? Last class you had done R divided by 1 plus JXC, whatever you have done in network analysis. I want only the across this total voltage into how you have done last class V1 equal to only the components were interchanged. Now are interchanged. Earlier it was a R, here it was a C. Therefore I got V naught equal to 1 plus RF by R1 is again correct, all of you are told, into Vin into this whatever J2 pi FRC divided by 1 plus J2 pi FRC. Copy down this and try to understand. A remaining procedure, design, other things will remain same, the way how we have done it for a low pass first order Butterworth filter. And this is sometimes I am spending more time because I know people do the mistake there only. And most of the students they write 1 plus RF by R1 into Vin because we had a habit of writing that in previous circuits. Because in the previous circuits we used to give Vin directly to the non-inverting terminal. That's the reason we used to write 1 plus RF by R1 into Vin. But I am not giving Vin directly to the non-inverting terminal. Some circuit is there. So I had to see the voltage at non-inverting terminal. Then I had to say into gain is the output. Now, write down V0 by Vn equal to, you might have copied, whereas AF equal to 1 plus RF by R1, F equal to the frequency of the input signal, FL equal to 1 by 2 pi RC. Take a minute and copy down this. V0 by Vn equal to EF into bracket J F by FL whole divided by 1 plus J F by FL. AF equal to 1 plus RF by R1 is a pass band gain. F equal to frequency, input frequency in terms of hertz. FL equal to 1 by 2 pi RC. It is a low cutoff frequency. Take another 10 seconds and copy down. Hope most of you have copied. And since high pass are found by low pass simply by interchanging R and C, design and frequency scaling, everything will remain same, the procedure. So one point which you have to remember. And voltage gain, a magnitude is given by square root of, this is another equation you can copy down. And the procedure will remain same whether you go for a frequency scaling or a design of high pass filter, because only two components are interchanged. Remaining procedure is same. Since high pass filters are formed from the low pass filter, simply interchanging the R and C, a design and frequency scaling, all the procedure whatever I have discussed for low pass filter are also for a high pass filter. Okay, I hope most of you are copied. Let me go to the next. This is a second order high pass Butterworth filter. No derivation, directly you can note on the V0 by Vin equal to. But remember, AF should be equal to 1.586. This is one important point which you have to remember. So copy down, you can take a 1 minute. Only changes R and C positions are changed. And pass band and stop band will be now different. And instead of 20 dB, because it is a second order, it is a 40 dB per decade. So some of the points you just note down properly. In the circuit you practice, write down whether somebody is seeing or not, whether your parents are asking you to write down, sit properly, note down, whether the teacher is telling or not. Remember, it is your life. Remember, you want to learn. Remember, you want to do something in the life. You need a job. You need a good life partner. You want to earn something. You want to know something. Purely it is only on you. Never depends on your teachers. Or even depends on the parents. They should tell. No. It's your life. You decide what is good for you. But take another few seconds if you want. I'll give another 10 to 15 seconds. Copy down. And we will not discuss anything again, problem and all remains same. Only equations may differ. You have to fill the values and you have to find out. But remember, for second order, gain 1.586. In second order, we take R2 equal to R3 equal to R, C2 equal to C3 equal to C. These are some of the points you have to remember. In case of first order, 20 dB. In case of second order, it is a 40 dB per decade. Hope most of you have copied this. And third order is not there in the syllabus. But for your reference, as time is there today, 2-3 minutes you can spend on a remaining portion. First order plus cascading a second order. See, it's the first order, RC. RC, second order. So by cascading first order, second order, we got a third order. It's not in the syllabus. Just for your reference, take a 30 seconds. You can understand. We are cascading the first order and second order so that I can get a third order low pass filter. When I say third order, what is the dB per decade? Can you type your answer in the chat box? And the 10 seconds are there. What will be the dB per decade? How much we get per decade fall? Yes, Ulvesh. It is a 60 dB per decade, Anusha. Very good, Anusha. Abhinandan and Rakshita Karnan. And most of the students, they are not doing any project. They are not reporting. So please do it. Most of you don't depends on your guide, whether guide is telling or not, whether he is strict or not. It is your life. Please do it. Get all the knowledge so that you can survive anywhere and you can get placed in a core company. And Praveen PC, Rakshita, Pooja, Kalyan Mat has given the answer. Kirti Badigir, Srirang, Umakant. Most of them have given the same answer. Very good. Now, if I want a fourth order, I'll get a second order in cascading with another second order. Total I'll get a 80 dB per decade. This is also not in the syllabus. I take a 10 to 15 seconds just to glance at once how we can do it. So just cascade these two instead of this signal and load, connect this to here, so that second order cascading with another second order will get a fourth order. All these are not in the syllabus, just for your reference I am showing you. Earlier you used to ask the students to conduct this experiment exam in the exam directly. They used to do only second order, but we used to ask third order. They should have common sense to do design and show it. Later they can do even a normal experiment only. And this is about a fourth order. And wide band pass filter, what I have discussed. How we get a band pass filter. This is a high pass filter cascading with the low pass filter, will get a band pass filter. This is a high pass filter cascading with the low pass filter. Use your common sense. I used to spend a lot of time for this because it was there in the syllabus. Now you understand. Can I do a low pass then high pass? What is the problem? I want like this shape. No doubt it is having a high pass also, low pass also. This, if I take straight line, it is a high pass. If I take this, it is a low pass. So I had to cascade, but how? Which one is first? Why high pass first? Think on that. And similarly, this is circuit diagram, just I am cascading. And band stop filter if you want. So this is like a high pass, this is like a low pass. So now low pass filter and high pass filter, I need both. How to connect? Can I connect series or parallel? That you just spend a little time. This is a common sense, and this is a way how we can do. Low pass and high pass, use a summing amplifier so that you will get a band stop filter. This is a complete circuit for your reference. I am taking a high pass filter, I am taking low pass filter and summing amplifier which I have studied, so that I will get a total band pass filter. And all pass filter, the name itself gives the idea. All pass means every signal will be passed. Then what are the use, sir? This is having some application in some of the, I think it is there in the next slide. These are used in the telephone lines. The signal undergo change in phase to compensate all pass filter. See, I'll show you the next slide. Try to understand. All pass filter also called as a delay equalizers or phase correction. So phase will be differ depending upon the frequency. So all pass filter is also not there in the syllabus. Just for your reference, I have discussed. And let me ask you the one question, or before that, summary you go through. First order high pass filter you have discussed. Derivation of a gain. Second order high pass Butterworth filter. Wide band pass filter. Band stop filter using a low pass, high pass, how we can do, and all pass filter we have discussed so far. And up to second order high pass Butterworth filter syllabus, you have wide band pass, band stop. It is for your reference. If somebody asks using common sense, can you do it? You have only high pass and low pass second order. Can you do third order? Can you do fourth order? Can you do wide band or band elimination filter? Yeah, you should have some idea. And another 3-4 minutes are remaining. In that, let me take 1 minute. And this is the end of the filter topic. And I will ask one question. Then those who are interested, you can give the answers, and then we will try to conclude today's class. DC to AC converter. Do you know? If you know, type your answer in the chat box. Thanks for attending the class. Take care of yourself. Be safe. I'll be here for another 3-4 minutes. Those who are having doubts, those who want to talk to me, I'll be happy. I'll be here for another 3-4 minutes. We can leave the class now. Thank you. Take care. Bye.